now start our discussion. Continue, okay, our discussion, okay. So this is where we've stopped last meeting, secret number 8. So this is where we are now. But before we continue this one, do you guys have clarification or questions regarding with your activities from,
Sir, may nagpapasabi daw po, sir.
yes? Yun.
Sir, hindi daw po makakapasok si Cameron. Nasa hospital daw po, sir.
Oh, anong nangyari? Alam mo kung anong nangyari? Kung bakit siya nasa hospital?
No, sir. Sinabi lang po sa akin na nasa hospital po.
I see. So I hope nothing too serious happened so that she can still, he or she, hindi ko alam kung lalaki ba siya babae, he or she can still take his final exam. Alright, so Mr. Cameron is here right now. So he said that he's using his mother's phone. Anyway, so this will just be a quick discussion. Alright, so are there no other question anymore? Or clarification or concern?
Wala na po, sir.
Alright. Okay, so for the next topic, we have here the applications of functions, wherein we have this mod, okay? Or in other words, we call this one modulo or modulo, okay? So this one refers to the remainder of the division written as x mod y, okay? So this one is actually similar with division, okay? It's just that it has a flip, yeah, a flip operator. All right. So if we have the divide, okay, or divide something like that, like 3 divided by 5, for the modulo, if you're going to read that one, 3 mod 5. All right. So it's a flip division operator. All right. And then if you're going to do this one, 3 divided by 5, of course, you will get, okay, let me just get my calculator. So you will get 0.6. Okay, at exactly 0.6. But if you're going to do the 3 mod 5, you will get 3. All right. So how did this happen? Because in modulus or modulo, okay, what we're trying to get is the remainder. Right. So what do we mean by remainder? So let me give you guys another example. So 6 modulo 5. So the remainder of this one is 1. Okay, so that's the answer for this one. So were you guys able to get the concept of modulo now? Or still not clear? All right, so I guess you guys didn't guess you didn't understand this one. All right, so let's have another example. 11 modulo 5. What is the result of this one? Anyone?
1.
Lucky guess. 1. All right, so as you can see, 11 divided by 5 is 1. Why? Because the remainder is 1. So it's like 5, 10, or like, doing the normal way of dividing things. 5 divided by 11. So 5 times 2 is 10. Remainder 11. Oops. So this one doesn't matter. What matters is the remainder. So this is our answer for this one. Right. Oops. Okay, so that's how we calculate mod. All right, so let us try to answer this example. Okay, so 6 mod 2 is equal to 0. 5 mod 1 is equal to 0. Actually, any number that is mod by 1 is 0. Okay, because as you can see right here, our condition for x and y are always positive integers. So we'll never get, okay, call this one a decimal. Okay, we'll never get 5.5, 6.5, 7.5, and so on and so forth. Okay, it is always positive integers, okay, where it's whole number. And then for the third one, 8 mod 12 is 8. Okay, and one more thing, if our divisor wasn't able to divide your numerator, then whatever is the value of your numerator, that will be your remainder. Okay, same with this one. Letter C. And then for the last one, 199,673 mod 2 is equal to 11. Okay. And yeah, as you can see right here, we also have here another pattern wherein if we have a result of uh, odd number that is divided by 2, the result is always 1. Okay. Well, uh, another condition here is as long as the numerator is greater than the denominator, right? The result here is always 1. But, to avoid confusion, you can just always use your calculator. Okay. So just get the remainder. All right. So were you guys able to understand this one now? The applications of functions mod?
Yes, sir.
Yes, sir.
All right. Okay. So again, if you guys are confused, please let me know. Okay, so let's have another example. So let f be the function from x, 0, 1, 2, 3, 4 to x defined by f of x is equal to 4x mod 5. So here are the questions. So it says here, write f as a set of ordered pairs and draw the arrow diagram of the following, or of f. Okay, so let's answer this one. All right, so I will list all of the x for now, and then we'll list them one by answering with the corresponding on x. Okay, so our x here is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay. And then our another x wherein I'll just define it to y to avoid confusion, or to have an easier way of calling this set. So we have here the f of x is equal to 4x mod 5. So if we have 0 for this x, so 4 times 0 is 0. So 0 mod 5 is 0. All right. And then if we have 1, so 4 times 1 is 4. 4 mod 5 is
4.
4. Can you guys follow?
Yes.
And if we have 2, so 4 times 2 is 8. 8 mod
It's
5 is how many? 8 mod 5,
yeah, 3.
3. Right, very good. And if we have 3, so 4 times 3 is 12. 12 mod 5,
2.
okay, very good. And if we have 4, so 4 times 4 is 16 divided by 5, or 16 mod
1.
5, 1. Right, very good. So it says here, write f as a set of ordered pairs and draw the arrow diagram of the following. So if you're going to put this in a set, so we have here 0, 0. We have here 1, 4. What's happening there? And then we have 2, 3. What is that? Right. 2, 3, and 3, 2. And lastly is 4, 1. Okay. So here's the set of ordered pairs. Oops, sorry, this one should be enclosed with parentheses. And then says here, draw the arrow diagram of the F. So just simply do this one. Okay. So here's now the arrow diagram of this function. Okay. And then for the last one is F 1 to 1 or onto. So what, guys? Is this 1 to 1?
Yes, sir.
This
Yes,
onto?
sir.
Okay. So if this is 1 to 1 and onto, what is that again? What is that relation? Where you guys forgot? So if it's 1 to 1 and onto, we call that one bijection. Alright. So this relation or this function is a bijection. Okay. So are we clear with this one?
Yes, sir.
Yes, sir.
All right. So next we have here the hash functions. So this one takes a data item to be stored or retrieved by computing the first choice for the location for the item. Okay. So basically this hash functions is came from the mod, okay, or the application of functions wherein it is connected with our database. Okay. So this is actually how the computer store our data with the use of hashing. Okay, like for example, we have n mod 11. So depending on the size of your memory, so like for example, for now we have a memory of 0 to 10. So take note, in memory we don't start with 1, or in computer we don't start with 1. We always start with 0. Okay, 0 and above. Okay, so as you guys can see, 0 to 10 is a total of 11 characters. So that is why it's mod 11. All right. So depending on the storage of your memory will be the limit of your modulus. All right, so let's have an example for you guys to appreciate this one. So start the following values in the memory using hash function. Right, and we have here data 15, 558, 32, 132, and so on and so forth. Okay, so as you guys can see, we have here cells 0 to 10, wherein some of them are already filled with those values 15, 558, 32, up to the 5. All right, so how did we put this 132 here, this 132 here? Okay, so for now, let's start with 15. So as you guys can see, 15 mod 11 or n mod 11. So everything, all of them are mod 11. It's just that it's changing the value or the one that you're going to store. Okay, so no matter how high, no matter how low that value is, okay, you need to perform this formula, mod 11, okay, depending on the size of your memory. Right, so 15 mod 11, as you guys can see, we have here a remainder of 4. So just look for that cell, which is this one, so 4. So just store the 15 in there. We have 558 mod 11. We have a remainder of 8. Just store it on the 8th cell. 32 mod 11. We have here the 10th cell or the remainder of 10. So just put 32 there. 132 mod 11, we have 0. So just put the 132 in 0 cell. 102 mod 11 is equal to 3 or having a remainder of 3. So just put it on the 3rd cell. Okay. And then lastly, 5 mod 11 is a remainder of 5 or equal to 5. So just put the 5 on the 5th cell. All right. So as you guys can see, we still have enough space for the next datas. So for now, did you guys get on how did we put those data on our cell?
Yes, sir.
Yes, sir.
All right. So just follow this one, okay? So the one that you're looking for, the hash functions, is the count of cells or the count of memories or the memory itself, and then the n here or the data that you're going to store. All right, and then just follow this one, and you will be able to do this kind of answer also. All right, so here's the continuation. If h of x is equal to h of y, but x is not equal to y, then a collision occurs. What do you mean by collision? There is two data that is occupying the same cell number. All right. So for example, we have here 4,257 as a new data, okay, wherein of course we're still going to use this formula since we're storing that one in the same database or storage. So as you guys can see, we'll have or we'll get a remainder of 4, wherein our fourth cell is already contained by the data number 15. So we have a resolution for that one. So collision resolution policy. So used to solve collisions, it may be finding the next highest unoccupied cell. So just look for the highest unoccupied cell. Okay. So we'll start with the lowest, of course, up to the highest. So just 4,257 will now go to your 6th cell. Okay. So you can only do this one if there is a collision. All right. If two data is occupying the same cell at the same time. Actually, not at the same time. So actually, in hashing, first comes first served. Okay, and then the next data will just find a new slot that you can go to. Okay, so for 4,257 will go to your 6th cell. All right, so that's how we call this one, how we store data in our database or storage in our computer, the use of hashing. So were you guys able to get this one so far?
Yes, sir.
All right.
Yes, sir.
So once you're done with those examples, then again, you may now start in answering this seat work number 9. Okay. So I will leave this one to you now. So let us now proceed to the next one, or to the last topic, which is the floor and ceiling of X. All right, so to make it short, when we say floor, so as you can see, it's the ground floor. Okay, it rounds down the number. And if we have the ceiling, so it's the above top portion, it rounds up the number. All right. So when we say floor and ceiling, so it doesn't matter what is your decimal. Okay. So unlike in normal way of rounding up or rounding down things, if it's uh, 0.4 and below, okay, you round down that number. And if it's 0.5 and above, then you round up the number. But in floor and ceiling, that's not how it works in this kind of uh, process. Okay, so as long as you have one uh, remainder or one decimal like 0.01, 0.1, or 0.0001, no matter how small it is. Okay, so you have to round it down if it's floor, and then you have to round it up if it's ceiling. All right, so as you guys can see right here, we have 8.3 will be round down, okay, which is now equal to 8, and then negative 8.7 will be more round down, which is negative 9. All right, so were you guys able to follow this one?
Yes, sir.
Okay, so don't get
Yes, sir.
confused in this one. Okay, this one just becomes more smaller. Okay, that's why it's gets more round down. Okay, we didn't round this one up, but instead we did round this one down. Okay, from negative 8.7 became negative 9, which is much more lower or lesser. All right, so we have the ceiling right here. If it's 6, or if it doesn't have a remainder or a decimal rather, then it will stay as it is. However, if it already have a remainder or a decimal, so even though it's 0.1 or 0.0001, then it will round up to the next number. So 9.1 will become 10. So the same with this one, your negative 11.3 will be round up. So this one will become negative 11. All right, and then negative 8 will stay as it is. All right, so did you guys get the idea of floor and ceiling?
Yes, sir.
Yes, sir.
All right, so let's have a graph representation here for the floor. Okay, so if it's ranging from 2.0 to 2.9, then it will be round down to 2. If we have 1.0 to 1.9, it will become 1. If it's 0 to 0.9, then it will become 0. If we have negative 0.1 to negative 1, it will become negative 1. Negative 1.1 to negative 2 is equal to negative 2. And negative 2.1 to negative 3 is equal to negative 3. Okay, so if we have a remainder, why do I keep on saying remainder? If we have a decimal, okay, so when it comes to flooring or floor, you will always go to the smallest or lowest number. All right. So this is the graph representation. This is the positive 1, positive 2, and positive 3. So we have here 2.0 to 2.9. So as you guys can see, this is the ground or the floor area. Okay, so it will fall on this one. So the same with this one, 1.0 to 1.9, it will fall on this one. This one, this one, this one, and this one. So this symbol is like I don't know how to say this one, but this one, okay, this one and this one, this is like the final coordinates of that value. All right. So if you're going to plot this one, then you will plot it here, 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 here. So they are connected right there. All right. So were you guys able to follow this one?
Yes, sir.
Yes, sir.
All right. So we have here the graphs for the ceiling. So this is the opposite of your floor, of course. So as long as you have a remainder, if you have a decimal, okay, then it will be round up right away. So as you guys can see, we have 1.1 to 2. It will be round up to 2. So as you guys can see, the symbol is now flipped. Okay, so this is now the final coordinates. If we have 0.1, it will become 1. If we have negative 0.9, it will become 0. If we have negative 1.9, it will become negative 1. Negative 2.9 will become negative 2. All right, so those are their final coordinates. And then if you're going to plot this one, then you will plot it right here, 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 here. All right, so are we clear for this one?
Yes, sir.
Yes, sir.
All right, so this is the last one, plotting the graph. So this is just an example. So plot the graph of the function f of x is equal to 5 plus 3, and then we have here ceiling, okay, wherein our x's will start at 5. Oh, why? This one should be negative 5. All right, so there's a correction on this one. Negative 5 is less than or equal to x, or your x is ranging from negative 5 to 5. All right, so negative 5 to positive 5. All right, so let's try to answer this one. So again, correction. This one should be negative. Oops, negative 5. All right. So let's now list all of the ordered pairs for now. So f is equal to, all right, so I think it's kind of difficult in here. So we'll just use Notepad. F equal to, so how many ordered pairs do we have? 5, 10, 11. 4, 5, 6, 7, 8, 9, 10, 11. Right. Comma. All right, and then we have here the x, wherein it's starting from -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and then 5. All right, so if we have a value of -5 for this x, so -5.1 will become -5, right? So -5 times 3 is -15. -15 plus 5 is +10. Okay, so I just did it manually. I hope you guys were able to follow on how did we get this +10. Sorry, -10, right?
Yes, sir.
So for the next one, we have here -4. So -4.1 will become
4. -4.
-4. So -4 times 3 is -12, right?
-12.
-12 plus 5 is
-7.
-7. Okay. And then if we have -3, so -3.1 will become
-3.
-3. So -3 times 3 is -9
-9.
plus 5 is -4.
4.
As you guys can see, we already have a pattern in here. So it keeps on
Yeah.
adding 3, right?
Adding
So
3.
-10,
Yes.
-7, -4. Then we have here -1.
-1.
So plus 3 again, we have here 2.
2.
And if we have 0, so
5.
0.1 will become 1. 1 times 3 plus 5 is 8.
2.
All right. So in here, it jumped from 3 to 5. Okay, so it's now plus 5. But of course, once we're done with the 0, it will become plus 3, plus 3, plus 3. All right, so if we have here +1, so 1.1 will become
2.
2. Okay, so 2 times 3 is 6, plus 5 is 11. So as you guys can see, it is now adding 3 and 3 and 3. So 8, 11, 14, 17, 20, and then 23. So if you are not convinced that this is the correct ordered pairs on every number for your x, so please verify those. All right.
So I have a question though.
Yes.
Our function, is it supposed to be -5 greater than or equals to x, or -5 less than or equals to x greater than or equals to 5? Less than or equals to 5.
Less than, yeah, should be your x should be less than or equal to -5, and your x should be greater than or equal to 5. So
Greater
that is why
than?
we have the, yes.
I thought it's less than. We use -5 to 5.
Yeah, we've used -5, -4, -3, -2, -1, 0,
Yes.
1, 2, 3, 4, 5.
That means our x is less than or equals to 5, not greater than or equals to 5.
What do you mean?
I mean the function -5, it should be -5 less than or equals to x less than or equals to 5. But we have greater than in
I
the
see. So you're talking about the condition.
yes.
I see. So maybe this one is confusing. But what I mean on this one is your x is ranging from -5 to +5. Okay.
Yeah,
So the
I
order
understand. I'm just worried maybe when we have an assignment, we won't get it wrong if you see a function like that.
in your assignment is what?
No, I said I'm just wondering maybe when we have an assignment so that we don't get it wrong if you see a function like that.
Pardon?
I said I'm only worried that in case we have an assignment or any function that has to be like this so that we don't get it wrong. So that the greater than or the less than sign doesn't confuse us. That's all right.
Yeah. So if there is another condition, then you have to follow that one. But in here, the condition here is already the function. Okay, so just follow this one, and then this is your x, and then your f of x is your y. Okay, so remember in plotting the graph for the f of x, where is that one again? Right here, your f of x here is actually your y. Right,
Yeah, I understand.
Okay.
The only thing I'm confused about is the function, the greater than and equals to, because if I'm to consider the greater than and equals to, then that means my x will be 6, I'll be 5, 6, 7, 8, 9, because it's greater than 5.
Oh, wait, let me check.
It said greater than or equals to 5. That's what I'm
Less
talking
than
about. This
-5. Ah, yeah.
it should be less than or equals to.
So this one is incorrect. Okay, my bad.
Yes.
So this one should be. So there is a correction on that one. This one should be 5 or equal a -5 your x, and then less than as or
or
equal
equals
to +5.
Yeah.
I see. Okay. So please do change this one into here. So this one is ranging from -5 to +5. All right. So that is why Mr. Walawewe is confused. All right. So thank you so much for this one. I didn't notice that this one is actually incorrect. All right. So anyway, that's how we list the ordered pairs using the range of -5 to +5. So it says here, plot the graph of the function. So just make a graph. So the same with this one. Or is that the same with this one? Then you will get the line or the graph of that one. All right. And since you don't have enough time anymore, okay. So this is your seat work number 10. Okay. So yeah, that's it for the module 5. And then the coverage of your final exam is module 3 to module 5, of course. So any
Okay.
other concerns so far?
No,
Wala
sir.
naman po, sir.
All right, so I guess that's it. So good luck with your final exam this week. Okay, so I don't know the exact date, maybe Thursday. All right, so
Thank you,
goodbye,
sir.
guys, and thank you.
Bye.
Thank you,
Bye,
sir.
sir.
Thank you po. Bye,
Goodbye.
sir.
Bye, sir.